Hi, my name's Amal and I'm here today to talk to you. Manufacturing or industrial engineering is the production of products for use or sale using people and machines, tools and chemicals or biological processing or formulation. It can be producing raw materials or finished goods, and there's multiple ways of producing that, either via batch, job, flow, and you'll often hear terms like lean manufacturing or agile. I think the easiest way to explain it is as part of a supply chain where raw materials are often provided to the manufacturing plants through suppliers. These are then distributed to the customers, to the end user or consumer like you and me. The largest sectors of manufacturing are food and drinks, such as apples or crisps to burgers and cookies, transport from cars to bikes, pharmaceuticals and chemicals such as medicines, nail varnish remover or aspirin, and electronics like TVs, mobile phones or gadgets. In total, 10% of the UK economy comes from manufacturing and 8% of UK jobs. So what does a manufacturing engineering do? Ultimately, there is a huge variety of roles, and what we do each day is work with people, equipment, data and systems. Depending on which area you work in, you could be designing the future project, understanding consumer needs to ensuring the production line delivers 200 units a minute, or ensuring the delivery of orders to the customer. There are many ways to do this, and a good way to understand how to improve manufacturing is the lean methodology, mainly to deliver on time, to standard, and eliminating waste. The other great thing about manufacturing now is the focus on the entire life cycle of a product to ensure no impact to the environment and our world that we live in. So next I'd like to talk to you about my journey so far. I got a mix of A stars and A's in maths and science and a B in English Lit. My A levels were unusually maths, physics and sports science because I liked to see and apply the theory that I learnt. I took a gap year and part of that was living in France. Most notably, I was the first girl engineer in this factory that you can see in the photo on the left. And then at university, I'd studied manufacturing engineering. I initially wanted to be an aeronautics engineer. However, after doing 2 years general, I realised I was much better with people and problem solving, and I didn't want to be designing a specific wingtip. I then joined Procter & Gamble, and I was a process engineer making washing powder on the packing lines. I then became the area leader, so looking after 2 production lines in the teams, and then after 4 years I was running the entire packing department. I then went on to do various director roles such as quality improvement and initiatives and material process design, and that's the roles I did making Gillette gel, foam and Old Spice antiperspirant. I then joined NPL last year as head of department, and I'm going to talk to you more about what happens there. So what is my workplace like? NPL has several sites, but the place where I work is in Teddington, and it's got 400 science laboratories, of which my department runs 20, and it's full of amazing people, and total 1,000 at the moment. We provide confidence that the goods and services we buy live up to their claims, that medicine we take are the right dosage, and that the data we use for everything from climate change to financial trading is accurate. We are the UK's National Measurement Institute, and we make science scientific, and it's a bit more than maths, enabling science, engineering and trade. NPL's work focuses on 4 sectors to reflect societal changes, ultimately tackling the measurement challenges that help improve the quality of life for the UK. And you can see we are split into 4 main areas of advanced manufacturing, life science and health, environment and energy, and digital underpinning it all. To help illustrate what that means and who we work with, NPL has such a large range of organisation. I've been able to give you a snapshot here of the different types of industrial companies to governments worldwide, regulators and institutions such as universities. We ultimately drive innovation and product development, uncovering efficiencies, driving growth, and trying to make the world a better place. So what do I do all day? I mainly help my teams fix problems, either it be equipment, approval to do work, funding for the next COVID sensor, contracts for our new staff members or students. I love to support the team of coaching or problem solving with them. And I do this through working with people across, firstly, NPL, from marketing, legal, commercial, safety and quality, and then working with people outside the company, such as universities, industrial companies and institutions. The best part for me is helping people and fixing problems, and ultimately driving for a better future, improving life for all, such as fighting cancer, helping the environment and helping companies grow. So what are the challenges in my role? Well, unfortunately, sometimes things take longer than expected, so it means a lot of replanning or trying to find a way through to make sure we get the end goal. And there's often too many emails and lots of meetings. So I'd now like to talk to you about STEM jobs in the whole of the UK. There are many jobs in STEM as these are growing rapidly and expected to double in 10 years. Therefore, I'd always recommend STEM if you like any of the subjects such as maths or the sciences or technology, as there's so many opportunities. The average salary is 40,000, with the majority of people satisfied and enjoying the work that they do. Most STEM professionals will have at least one degree, but not all. Some will join via apprenticeships or develop their careers from different starting points. Also, a STEM degree is highly transferable to other careers, and as you can see, half will go on to work in other fields such as accountants, HR and product managers. NPL strives to be the best, and therefore to do so we need to hire at that. We look for passionate people to make a difference, direct your own work and have ideas. Enthusiasm and people skills are really important. We support diversity, including worldviews, flexible working, physical and neurodiversity. Therefore, we recruit at all levels from apprenticeships, post-GCSE, university graduates to PhD students and experienced hires like me. Deep diving into our apprenticeships, over 60% of our apprentices stay on full-time employees, and some of those go on to university sponsored by us. A great example is one of the team members, Purdy, who was able to speak at the House of Commons about her career, engineering and diversity. NPL employs about 1,000 people and therefore we're usually looking for about 20 to 100 more each year. So, if you're still trying to decide what to study, a reminder, follow your passion. Do take any opportunity to try things out like playing sports, after school clubs, volunteering. Not only are they fun, but they'll also help you develop soft skills, which will help you in your life as well as your career. STEM subjects also support these soft skills, such as problem solving, leadership, and communication. You can see here the development of the skills and what percentage of the soft skills you'll gain from learning through a STEM subject. And you can see that learning and leading are the key top sort of soft skills that you may learn, down to coordinating, literacy, and project management. Ultimately, in any team, you need diverse and a different set of backgrounds is so important to improve and do the best that a team can do. So, how do you become a scientist or engineer? The jobs in STEM are so varied that you've really got a chance to follow your interests. There is no right way, but if you'd like me to give you an idea, I'm going to try and attempt to do so now. Assuming you'll do either GCSEs, A levels in a STEM subject and possibly onto a degree. You could join either through an apprenticeship, as an engineer, or as in a research and development route into industry. Your career could go into process engineering like I did, then a sort of leadership engineering role before taking over a department, which could then lead to a director role and ultimately potentially executive or CEO if that's what you'd like. If you prefer the more academic route or research route, you would then go on to do postdocs after your PhD, potentially then move up the career into research scientist, senior, principal, and coming up to chief scientist. Remember, this is just an example to give you an idea. There is no right way, and I always advise follow your passion. You can find out more about NPL via our academy that runs in July. People from your area have done this and gone on to join NPL, moved into research, done a PhD, became an engineer. We also offer school visits, so if you're interested, please talk to your teacher. I hope you found it useful to find out about manufacturing and STEM. I wanted to finish off to tell you anyone could be an engineer or scientist. It doesn't matter who you are, what your background is, or what you look like. In fact, the most successful teams I've worked with in my career had a whole range of people. If you'd like to have a go, please do try the measurement at home challenges. They're real science without the lab. That's all from me. Thank you for listening, and I've really enjoyed talking to you about manufacturing, my career, and where I work at the National Physical Laboratory.